So in this approach, I'm going to synthesize an offset slider crank, or in many instances it would be called a quick return or a quick extend mechanism. Okay, so in order to synthesize this type of mechanism, what needs to be given to you is going to be what's known as Q, or the time ratio. The time ratio is a ratio of slow time to quick time. Okay, so slow time is the time it takes to get from, say, this position 2 to position 1, and then quick time would be what it would take to get from position 1 to back to position 2. So that's going to be given to you, or if the Q is not given to you, the slow time and the quick time is going to be given to you. Okay. Some problems, they might give you a Q and the slow time, in which case you can calculate the quick time, or they'll give you Q and the quick time and you can calculate the slow time, or give you Q and the total time. If Q and the total time is given, then you can go ahead and calculate the slow time and the quick time. So from Q and a given slow time and quick time, we can go ahead and calculate what's known as this offset angle. Okay, and in this case, offset angle beta comes out to be 36 degrees. Okay, so essentially what we're saying here is the following. If we've got a crank, okay, and that crank is going to rotate about that center point, okay, to go from position 1 to position 2, it might go through this angle, and then to go from position 2 back to position 1, it'll go through this angle. A couple of things that you should make note of here is this theta 1 and theta 2. Theta 1 plus theta 2 has to equal 360 degrees. And if we draw a dotted line over here, basically what we're calculating is this beta angle. Okay, so 180 plus beta is going to be theta 2 essentially, and 180 minus beta is going to be theta 1. Okay, so that's essentially what we're calculating. So in order to synthesize this offset slider crank, the first thing that we'll do is we'll locate the axis of a pin joint on the slider. Okay, so in this case, we will locate this axis of the pin joint. We will call this E1, and we will call that joint E2. So this really is position 1, and this is position 2. So we've got that done. The next thing we do is we draw this joint in its two extreme positions. So this is the furthest the slider will move to the left, and this is the furthest the slider will move to the right. And so that's a pin connection E1 and E2. Now the next thing that we do is we draw a construction line. I got the dashed line here. This is the line that connects E1 to E2. But we're going to draw a construction line at some arbitrary angle. So this is just a construction line. This red line is a construction line at some arbitrary angle. Okay, so we've done that, and we can say this is through E1. Okay, I'm going to draw a second construction line. The second construction line in this case, these two lines are parallel. So these two lines are parallel. Okay, and that's through E2. Now, once I do that, I'm going to draw a line at any angle from the other extreme position at some offset angle beta. Okay, so in this case, I'm going to draw a line through E2 at an offset angle. Let me change the color here. At an offset angle beta. Okay, so in this case, I'm going to draw it at this offset angle. And this offset angle in our case, is beta, or 36 degrees. Okay? So I've drawn a line at an angle offset by this beta angle. Now the intersection of the blue line and this original construction line right here is going to be ground joint A. And so we can draw a ground joint A here. Okay? Now what we're going to do is we're going to measure the two extreme positions. So these two extreme positions we're going to measure from A to E1 and measure from A to E2. Okay? So in here we're measuring from here to here, and then we're going to measure from here all the way down to that point. Okay? So we're taking the distance from those two extreme positions. Okay? And what we're going to do is the length of the crank is half the difference between the distance. And so the length of the crank, okay, if we come over here, the equation for that is the length of the crank is equal to this AE1 minus AE2, absolute value of that, divided by 2. Okay? So now what we can do is the length of the crank, we can draw a circle around that joint A of the length of that crank. Okay, and this is not to scale here. Draw a circle around this joint. Okay, and this becomes the length of the crank. So what we end up with is a crank that looks something like that. Okay, and that's in line with the blue construction line. And so position 1 is going to be the crank, and then the second link that's drawn is going to be the coupler. Okay. Okay. So that's in the extended position. So these link 2 and link 3, link 2 and link 3 are in line with each other. Okay, and that's one position. Now, the second aspect here is going to be when link 2 is in this position, okay, and its link 2 is along the line of this construction line, the red line, and I'm going to draw it next to it, and then link 3 comes next to it and connects down here to E1. So in this case, what I still have is I've got my joint here, I've got a joint here, and then I've got a joint here, and in this case I'm going to have one joint here and then one joint here. So in this case then, position 1 in this case, link 2 and link 1 are in line with each other. Okay, so to go from this first position, to go from this orange link around is smaller than 180 degrees, and then to go from this orange position back around this way is greater than 180 degrees. So to go this distance is going to take less time than to go that distance. So this is the notional diagram for this. I'll give you a scaled example of this in another video. If there are any questions, don't hesitate to ask. Thanks for watching.